get started. First of all, I just really want to thank you for coming to this talk, because there are other talks happening and you picked this one. So thank you for spending your opportunity cost coming to this room instead of one of the other ones. There is a fair amount of content, so I'm going to try to answer questions as much as I can at the end. So if you have a question, write it down or make a mental note, and then there's a good chance that I'll probably cover it, because it's kind of like a story type talk where there's stuff and then there's more stuff and it just kind of builds. So hopefully I'll answer your question. If I don't, just definitely ask me, because I want to interact with you as much as possible. So that's it. Let's talk about technical debt. So let me tell you a little bit about why I wanted to talk about technical debt. Because if you go online and you Google this particular topic, there's tons of information out there already. There is tons of blog posts and videos and project management methodologies and all this stuff about it. And because of that, I really wanted to tell you why this personally matters to me. It's important to me. I joined a team 2 years ago where I started maintaining a software application that is a legacy application. It's an old application. It's been around for probably 15 years, and it has just grown with the business, grown with the company. And what I found is that maintaining a legacy application like that means that you're basically dealing with technical debt all day, every day, because there's something that's old, that's been around forever, that just lives on and on and on. So the application I work in is built in Perl. And if you're not familiar with Perl, it's basically one of the earliest programming languages for the kind of the web, or processing a lot of data that was kind of able to run on the web, outside of the basic languages, low-level languages. And Perl was released in 1987. That gives you a little bit of an idea of how old it is. Also in 1987 was I Want to Dance with Somebody by Whitney Houston. And so this is why I feel really immature when it comes to looking at something in Perl, as I was not released until 1990. So Whitney Houston beats me and Perl beats me in this area. So legacy applications, old systems, these things are still around. They're running banks, they're running transaction systems, they're everywhere, and they're kind of running a lot of infrastructure that we depend on. The thing about legacy applications is they breed technical debt. They're just a breeding ground for these bad practices and old code to just kind of live on. And when you look at a legacy application like I was, with kind of fresh eyes, new eyes, you can kind of see how the pattern of the application has changed over time. And what I mean by that is you can actually look at the code base and you can identify the different team members that have been involved in the team over time. You can see that this developer had a particular code style, or the team tried to implement some sort of design pattern that maybe worked and maybe didn't, or was only half implemented through the code. The business has changed over time. Different people have led the organization, so the application has actually been changed to fit business requirements over time, and that has caused just upheaval and change, and features added and removed, or kind of turned off and disabled. All this stuff happens with legacy applications. And so because I was joining this team, I wanted to know, how can I help this team? How can I be the best possible person to participate on a team like this and help solve some of these organizational challenges, these code challenges? I wanted to be a team player. I wanted to give as much as I could to this team and help them really accomplish their goals and do their best work on their team. So to do that, I wanted to learn about technical debt. And so the first thing I did is I tried to figure out, what does technical debt really mean? Where does it come from? What is this idea of technical debt? What does it actually look like in code? So let's talk about the definition of technical debt. I think it's really important to understand a problem before you try to solve it. So that's why I kind of go to the definition here. Technical debt is a metaphor, and it was coined by this guy, Cunningham. And when he came up with this term, he was trying to communicate to the stakeholders in his organization that there was code in their systems that was implemented, someone had written it, it was working, it was solving a problem, but they still needed to invest time to change it. And if you look at that thing from a business, if you look at that situation from a business manager perspective, you're saying, why do I need to change this? The code's already there, it runs, it provides value. Why should I invest resources into changing something that already works? And what he was trying to communicate to them is that yes, it works, but it slows us down. It prevents us from making bigger, faster changes quicker because it is old code that is hard to maintain. So he was saying, look, this is debt for us. This costs us time, it costs us money, it costs us effort. And when you put something like the debt metaphor into the software world, you can start to pull some other terms out of the finance world. So you can use words like interest and paying debt down and taking out loans. So there's a lot of other verbiage and phrases that you get to start using and apply. And so that's one reason he came up with this and why it works so well when you're talking about things like technical debt. When you're talking about debt, it's really important to understand that there's a proper mindset that you have to have. So what I mean by that is technical debt should not be completely always viewed as a bad thing. It's not always a negative thing. In fact, there are many cases where technical debt is okay to have. And there's a lot of cases where technical debt doesn't come as a result of bad decisions, but just the fact that the business was operating and they're adding features, and that's okay. Debt is okay to have when it comes to a software company. There's things that happen, things change, business requirements change, that's acceptable. An example of this, right, is let's say you want to go out and buy an expensive car or house or something like that, right? You can go into your bank account and pull out $50,000 and go buy a brand new Lexus. It's going to drain you out though, right? It's going to cost a lot of money to do that. Or you can go in with a down payment, make payments over time, but you can still drive that Lexus today, right? That's the idea with a loan. With a debt loan in the software world, you can actually do the same thing. You can cut some corners. You can decrease the quality. You can decide to not do important things like testing. You can do these things, and they're risky behaviors, obviously. But if you, as a business and as a team, acknowledge that you're going to do that, you're going to participate in that risky behavior, then you've said that, hey, this is something we want to do because it's going to give us value. We're going to get a feature to market. We're going to beat a competitor. We're going to add value to users. And so we're going to take the gamble. We're going to take the risk that we'll have to come back and deal with this problem later. And that's okay. So that's why the idea of mindset, having kind of a Zen mode when you think about debt, it's not fair to simply say all debt is wrong and all debt is bad. So what does debt actually look like in a code base? What is the physical manifestation of technical debt in your code? The first thing is duplicate code. Excuse me one second. Duplicate code basically is code that gets copy-pasted, right? I need this thing that does this particular algorithm or logic, and I need it in more than one place. If you have to copy and paste that function or that particular algorithm in 2 or 3 different places of your code, the first thing that happens is when you need to change it, now you have to change it in 3 different places. And you have to maintain that logic in multiple places. This happens to us all the time. We have to make a minor change to some piece of code, and then 2 weeks later we find out some other part of the system that was using the exact same type of logic also needs to be changed, and it hasn't been, and it's showing the wrong numbers, showing the wrong data, that kind of stuff. And we get calls like, why does this report show a count of X and this report show a count of Y? This should be the same number. People are complaining that their statistics are wrong, that their data is wrong, that they're not getting paid properly, that kind of stuff. It's because we change things and we don't change it everywhere. So duplicate code, huge technical debt area. The other area is inconsistent code. And this really speaks directly to code style. So I'm literally talking about white space in your code, whether or not you're cuddling your else's consistently, how you're breaking up lines, that kind of stuff. Now, your parser obviously doesn't care, right? It's going to parse, it's going to go ahead and process that code fine. But what this does is it causes visual debt. Most developers in big companies spend a lot of their time reading code rather than writing it. They're looking for bugs. They're trying to find what needs to change, where changes need to occur. And when you have inconsistent code, it's really messy, and it's hard to look for the things that you're trying to find quickly. So if you have a lot of code, inconsistent code, it makes it really hard to find those changes fast. Another problem that you'll probably have is parsing errors. Now, in PHP, parsing errors can be silenced. You can just say, hey, don't show errors, WordPress debug, false, that kind of stuff, and none of those errors ever pop out to the user. But what's happening in the background is the parser is still catching those errors. It's logging them perhaps to a log file of some sort, and it's still having to deal with like what happened to this thing that I was expecting to have happen. And it really kind of indicates that the person who wrote the code didn't understand very well what was going on in the application. They got some input they weren't anticipating or expecting, and this leads to bugs. This leads to data being injected into your database that you weren't expecting. This leads to pages breaking, functions not processing or returning properly. And so this is just evidence that you might not understand what your programming language of choice is actually trying to do. Another area of debt, slow code. Now, slow code is probably one of the hardest areas to like find and resolve because you don't necessarily know that it's going to be slow when you write it. I work in a dev environment where my database is trimmed intentionally to have much fewer records so that it's faster. The second I push that code out to a production system, it goes from a couple hundred rows to a couple thousand, 50,000, 100,000 sometimes. And so code that I've written that performed just fine on my local machine is going to start to get crumbly and slow under those large data sets. What happens with inflexible code is duplicate code. So this kind of results in that. Code that is inflexible, it's not modularized. It's important to note here, by the way, WordPress is not object-oriented traditionally. I'm a PHP developer who wrote a lot of PHP before coming to WordPress, and so I'm very used to an object-oriented style. So it's really hard for me to go into WordPress and not want to like boot up some objects. Not modularized code is not the result of not object-oriented code. Does that make sense? You do not need object-oriented code to write flexible code. Those two things are not tied to each other. I work in Perl, which is not really object-oriented, and kind of is, but not great. And we can write flexible code in that system. Flexible code is a developer saying that I'm going to write flexible code, and I'm going to make sure that this is modularized and reusable. If you aren't writing flexible code, it's not because of your programming language or your programming style. It's not because of WordPress. It's because you're not practicing good design principles with your code. Last area of technical debt is dead code. Does anyone have an idea what dead code might be? Okay. Dead code is code that you put in your system and then comment out and leave there. And just stays and stays and stays. And the problem with dead code is that people have to read it and try to like figure out why is this code commented out. If you have like a large block of code and there's just a little section that's commented out and you're trying to like debug a problem, you're going to be like, why is this code here? What is is there a comment? Like, why was this added? Why was it taken out? Why is it still here? If you're using version control, why wasn't it just deleted? Maybe the person who commented out doesn't work for the company anymore, and you can't even go ask them, like, what's the deal here? Dead code is a huge problem, and if you have a version control system, you shouldn't really even leave code like this around. Just delete it. And if someone really, really needs it, they'll go look at the commit log and they'll pull it back. Or they'll rewrite it from scratch and hopefully add some tests, and it'll be better than it ever was in the first place. Someone in my last talk told me about zombie code. And so as opposed to dead code, zombie code is code that's actually in your system that is not commented out, but it actually doesn't ever get used in terms of like the result that it gets. So it's just processed and just left there, zombie code. That was great. What causes technical debt? What happens when technical debt is propagated into the system? What's going on inside the organization? So I talked a little bit about like sometimes debt is okay to have. I want to cover like areas where debt occurs and where it's okay and where it's not. So the first thing is a technical loan. So I talked about this, right? It's the idea that the team is going to agree to engage in debt. We're going to take out a loan where we're going to cheat the system a little bit. We're not going to write great tests. We're going to push a feature out because the business says we have to. And the value for that is that we're going to gain customers or market share or make a whole lot of money, and then we'll pay that off later when we have time. It's really, really important that when you engage in a technical debt loan, that everyone in the chain of command from upper management to the software team to the developers agree that you pay the debt off immediately, as soon as possible. All right, what needs to happen here is the software team writing the code can't take out a technical debt loan for the organization without telling them that that's what they're doing, right? We call that identity theft in the financial world, right? Where you take out a loan without telling people, right? In the software world, that really cripples the organization because they don't know that you're doing that. If they're expecting a feature to be fully thought out and implemented and tested and flexible and easy to change, and the the software team implements that code, and they take out a technical debt loan, and then when the organizers of the company come back and say, we want to change this, the team's like, it's really hard to change. They're like, why? You didn't tell me that it was going to be hard. You just did it. You didn't communicate that there was going to be a problem. So you can't just do this without explaining to everyone, hey, this is what's going on. Another form of acceptable debt, proof of life. This is debt that happens just because the business is operating. This kind of stuff is where someone asks for a feature and the team just does it. And that's okay. Like, that should happen all the time, right? Your software team is there to service the company. It's there to provide features and values. So if those features need to change, if the business needs to make changes to continue to do business, that's totally okay. This is totally fine. This is an acceptable form of debt. This is just things changed over time and got a little bit outdated, or this code hasn't been maintained very well, but it was adding value, was giving value to the company, and that's okay. You should try to address it, but in terms of like the debt size, you should consider this like really small. This is not a significant amount of debt in your system. What is going to be a big problem, though, is when you have careless developers on your team. I'll explain that in just one second. So, careless developers. These are developers who are not willing to engage in best practices. So we have in the development world things like unit tests or system tests or code styles, code patterns, design patterns. These are things that professional software developers should be using as they write code. Version control systems, all of these things, the tenets of good software design and good software implementation. If your software development team is not using these tools, they're being careless, they're being reckless, and they're gambling on the company's dime, right? They're not considering the damage that they could be doing to the entire organization. This is careless development, and this probably frustrates me the most because I take a lot of pride in my work and the effort that I'm putting in to be a good developer, a quality developer. And so when I see careless development practices carried out by people who should be professionals, this really gets under my skin. Leadership needs to kind of insist that the development team, even though they're not developers themselves, the leadership of the company needs to encourage and enforce as much as possible adherence to those things like code reviews and code styles. They don't have to know what they are, but they can say, look, you can do a code review. Your team should be doing code reviews. Your developers should be looking at each other's code and making sure that it's of a high quality. They can enforce things like code style. You can have on GitHub or Bitbucket or any of those other code tools, you can enforce that all the code is identical in terms of spacing and line breaks and all those sorts of things. You can enforce this. And the person who's managing the team doesn't need to be a developer to go look at GitHub and see that the tests pass and that the code style checks have passed. Next category, careless management. Now this happens to a lot of software teams. Management comes and asks for a feature without understanding what that feature actually means for all the users who are going to be engaging with it. We have this problem a lot where the management will say, hey, change so-and-so's payroll commission. And they don't understand that when they change it for one person, it changes for like everybody and that kind of stuff. So we end up with weird like payroll problems, or someone works California tax law with a certain overtime rate and all these weird kind of rules that happen in different states. They're not really thinking about the changes that they're making to the system and how that impacts people. So management can a lot of times do better. They can really solve those problems. Like those problems are policy problems that management should work out really before the software team really needs to get involved, or they can do it together. Management can do better specifications. They can think through those problems before asking the software team to get involved. They can make sure their requests are defined, well thought out, and they need to trust their team to do good deliverables, right? Set reasonable timelines, trust the team that is going to be working on this to deliver responsible, well thought out, well tested code. I talked about 4 categories of debt, right? The unacceptable categories and the acceptable ones. I want to show you what's called the debt quadrant. And the debt quadrant was coined or invented by this guy, Martin Fowler. And it's really interesting. I think it kind of shows how code can end up in your system and what it kind of looks like when it has debt attached to it. So this will make a little bit more sense once the graph is up. We have 4 categories here. We've got reckless, prudent, deliberate, and inadvertent. And in a quadrant, that looks like this. And the bubbles are essentially the amount of technical debt that you can expect if your code is in one of these categories or in one of these groupings. So let's look at like the reckless, deliberate category, the upper left-hand part of the quadrant. Okay, this is the software development team that is being reckless. Sorry, it's in my notes. Okay, my bad. The reckless, deliberate category here, this is the team that is engaging in a technical debt loan, right? The technical debt loan is where the team is saying, we're going to go and we're going to implement this feature and we're going to cheat. We're not going to do the tests. We're going to cut some corners, and that is a very deliberate thing that they're doing, right? So it's on the deliberate side, but it's reckless because they're not doing the tests. They're not doing good software design principles. So it kind of lands in there, and you can expect like basically a lot of technical debt from that decision, right? The other side we have is prudent and deliberate. Now this is a team that is kind of like doing everything the right way, right? They have enough time, they've got enough tests, they're writing their code to a good standard, and they have well thought out, well designed requirements, and so the debt from that should be relatively small. They shouldn't be getting a lot of debt if they're doing everything the right way. The bottom left-hand corner, reckless and inadvertent, this is a team that just doesn't know what they're doing at all. Like this team doesn't have enough requirements, they don't have enough time, they are just copying, pasting code off Stack Overflow and hoping that it works. This is going to result in a ton of technical debt because the team just doesn't have enough information to do their jobs properly. And that's why it's reckless and inadvertent, because they don't necessarily know that they're doing it, and it's super reckless because they are really damaging the organization. And the other side of this is prudent and inadvertent, the far bottom right. And this is where the management team is really kind of abusing the software team, where they're asking for things and they don't know what they're asking for. They're asking for features and not giving enough time to implement them. And so the software team's kind of like doing their best to like service the requests, but the management team's just changing their mind all the time. And this is probably where we're at in my company, where we're trying our hardest to like deliver good features, do enough testing, do everything the right way, but management just kind of is like, we're going to change our mind about this. Now, this week it's this, next week it's that kind of thing. And so you get technical debt from this, but there's really not a whole lot the software team can do other than complain and say, this is a problem, we need to fix it. Okay. Let's pause for 1 second. Is everyone tracking? Is everyone following? Do we understand what technical debt looks like in our code? Okay. We understand why it happens. We understand, hopefully, that it's complex and it's not enough to just say it's all bad. Cool. Are there any questions? All right. The next kind of half of this is like what happens to software teams when there is a lot of technical debt and what to do about it. All right. I like this quote, no problem can be solved by the same kind of thinking that created it. And what's really interesting is that once you know about a problem, you need to like figure out how to solve it. And so now we kind of know what technical debt is. We know how it manifests itself inside of a code base. We know how it occurred in the system, and now we can like work towards a solution. So first of all, you can't ignore it. If you're ignoring technical debt, then you're doing the most damage. Imagine you went out and bought that brand new Lexus on a debt, and you decided to just never pay the car payment, right? just as you can imagine, in a software team, that's going to result in a lot of problems, right? Bad things start to happen. Debt collectors are calling you. The IRS is complaining that you haven't paid your taxes, maybe. That car is going to go away. So just like that, a business is going to start to suffer if you have technical debt and you haven't resolved it. Some of the other things that start to happen to your team if you don't pay off technical debt. The first thing is the slowing of development velocity. So just like physics, the term velocity measures how much distance or how many things can be accomplished in an amount of time. Is anyone familiar with this term in like the project management field at all? Yes, a little bit. So we have some people in here. Okay. So basically, velocity measures the amount of work that can be accomplished in a set timeline. So let's say 2 weeks. Your team can accomplish maybe 10 or 15 tasks in that 2-week, what's called a sprint. All right. These terms come from a project management methodology called Scrum. This isn't a Scrum talk. I'm not going to try to like explain Scrum, but 2 words I want you to understand: velocity and sprint. Velocity, how much stuff you can get done in a set period of time. Sprint is the set period of time. All right. What you'll find on a team is if you break down the amount of work that you're doing in a sprint and then break that down into 2 categories of features versus debt service, you can start to understand how much technical debt is costing your team in terms of productivity. All right. If you add up everything here, you find that there are 11 debt points and 33 feature points. Points is the amount of work in like this kind of made up point system. Like hard tasks are high points, easy tasks are low points. This team is relatively healthy in terms of its debt. It has a low amount of debt. It's not spending most of its time managing debt. It's able to add features relatively easily. They have flexibility in needing to do work. They can get a lot of work done in a sprint. This is a healthy team. All right. An unhealthy team is going to have a sprint velocity that looks like this. Much higher levels of debt. You can see they have more debt points than feature points. This team is experiencing the pain of technical debt slowing them down. They cannot deliver enough features fast enough. Management is complaining that they're not producing enough code fast enough, and this is a huge problem for them. This team is in an unhealthy state. The last talk I did, someone told me about technical death. Technical death is when the debt rises so high that the team is basically, everything that they do takes months because it's a minor little thing, but there's so much technical debt that the team just cannot operate. Technical death is where the development team's like, we got to start over. We're building this from scratch, or the business is actually going to fail as a result of the technical debt in the system. This is bad, right? There are ways to fix this, and I'll kind of cover a little bit about that at the end. Other things that happen to your team. Lack of team growth, right? I'm talking about things like professional development. You're all here at a conference. You're developing yourselves professionally. A team that has a high level of debt probably can't come to a conference like this because they're spending their weekends working hard to try to produce some feature that management has asked for, and they're behind, right? There's going to be a huge amount of this on a team when they have so much debt that they can't enjoy their weekends, right? They don't have time for professional development. Everything they're doing takes a long time. They're stressed out. Their weekends kind of aren't that great. They don't enjoy work. The people on these teams are suffering, right? Another thing that happens is broken windows, all right? And I'm not talking about this broken window. Broken windows is a theory that was introduced in the 1980s. And the theory essentially goes that if you have a building and you break one of the windows and you leave it broken, the neighborhood starts to look at that building with a bit of a negative viewpoint, and crime in the area or in the neighborhood or in that building starts to increase. So it starts with a broken window, and then someone breaks into the building, and then someone puts graffiti on the building, and then eventually someone lights the building on fire and it burns down, right? The idea that one minor little thing can have this huge impact over time, this happens in code bases. If you have a development team where someone cheats a little bit and says, I'm not going to write a test for this, and then a developer comes and says, well, we didn't write a test for that, so maybe we won't write a test for this. or a new developer comes on and doesn't realize that some particular section of code performs really badly. And they take that example and they use it somewhere else. That gets repeated and repeated and repeated, and then over time, the entire code base becomes infected as a result of one bad decision because we let it go once. So if you have the opportunity to start on a new software project, don't let your guard down. You have to be proactive. You have to say, like, no, we're going to follow best practices all the time, because the one broken window will be the downfall of the entire system. I talked about this a little bit, but developer burnout, right? So that's the lack of team growth. The people who are on the team that has a lot of high technical debt, those people don't like their jobs. They don't like the code bases that they're working on. They don't like the software that they're working on. They have no passion for it. And quite frankly, they're tired of dealing with spaghetti code, and they get new jobs. They quit. They're out. Obviously, the cost to the company is huge here, because when you have people who leave, you have internal knowledge leaving with them, right? You have years of experience, years of knowing the system, the APIs, the code base. Those people are out the door because they hated their job so much. They're looking for new jobs, and it costs a lot for the company to replace them. Team conflict. So with a team that has high levels of technical debt is, quite frankly, an uncomfortable work environment overall, because there is blame. There's that person told me to copy this code from this section and it had a bug in it, and now it's their fault that this happened. Or the finance team asked us to implement this payroll logic and that had a problem with it, and so now we overpaid or underpaid some employees. That kind of stuff. This just is not a fun team to be on. This is poor work culture. It's not a positive team. People are yelling at each other or just subliminally like sending nasty messages on Slack or something like that. This is not fun. I mentioned like interdepartmental conflict. This is where other departments are getting involved in the fact that the software team has technical debt. So you've got users actually suffering. And at this point, technical debt is leaking outside of the software team into other teams. Other departments are being damaged. The team, the company overall is suffering. So this tiny little bit of technical debt is impacting the entire organization in a big way and causing huge amounts of performance problems. Ultimately, we've got turnover, attrition. People don't want to work there. People leave. They're out, right? So what do we do about it? How do we find technical debt? How do we get it out of our systems? There's a couple of tools I want to tell you about, and these are basically generalizations. You can Google and find like exact code or code tools to implement, but these will give you some keywords to like start with, all right? And I'll give you specifics later. First thing that you can do is you can turn on strict mode in your compiler, whatever you're using. Turn on strict mode, put all those errors in a log file. Like, don't put it out to a user. Like, the user doesn't need to see all that stuff, but you can log all this stuff, and then you can take a log file to your development team and say, all right, what's easy to fix here? Can we get some of these errors to go away? Can we do some better checking? Can we do some better tests? Next week, look at the same error log, see if you've got those errors out of there. That's an easy way to like find bad code and get it out of the system. Another thing you can do is a code analysis utility. So these are called static code analyzers. They're very popular in PHP. They're not so good in Perl, which kind of sucks for me. But JavaScript has them, Java has them, C, C++, C#, all that kind of stuff. These tools will inspect your code, and they'll tell you if your code is messy. They'll tell you if your code is hard to read or understand based on algorithms. It will tell you if you turn on strict mode how many errors you're going to start getting. It will tell you if your code is copy and pasted in 3 or 4 different places. These tools are really powerful, and you should definitely like look at them if you have a large code base, because it makes finding these types of problems a lot simpler. And you get basically an index or scoring on your code, and it tells you how to fix some of these problems. If you have a code analysis utility, you can also install those in your IDE. So does everyone know what an IDE is? Should I explain that a little bit? All right. Who here edits code with like something like Sublime or Notepad or Dreamweaver, that kind of stuff? All right. Good. That is the right way to like get started. An IDE is a integrated development environment. And what it does is it allows you to open a file with code in it and then look at all of the other code surrounding that file and it will give you intelligent information about the code that you're working on based on the code associated with it in the project. So for a really basic example is if you start to type the name of a function, it will see that you've defined this function in some other file, and it will tell you what the name of the function is. It'll tell you what type of methods or options that it takes. It might give you a little comment about what the doc block of the function is, what it returns, what to expect from it, if it has tests associated with it. The point of an IDE is to give you context. It gives you information to allow you to make intelligent decisions about the code you're writing and whether or not you need to do certain things or handle certain cases. If you don't use an IDE, definitely go check out a couple of them. They're free ones. They're ones that you pay for. If you're working in WordPress, the one that I prefer is a PHP editor called PHP Storm. It's extremely popular. It is a commercial project or a product, but it is by far one of a well-adopted tool. I'm a big fan of it, and I definitely encourage people to check that out. Another thing that you can do is a code quality gatekeeper. So in a normal environment where people are adding code, people can just put a commit in with a version control system, add some code to the system, and that code is now going to be in the system forever. With a code quality gatekeeper, you can use basically the data from code analysis to decide whether or not the code that's being added to the system is at a high enough quality level to be added before it actually gets included into the main line of the source control system. So basically, you can say, no, that code's not good enough. And you as a manager don't have to do that. A machine will tell the developer, no, this is not good enough, do better, before they ever get the code integrated into the main system. This takes a lot of time off, code reviews and that kind of stuff. It just speeds everything up. And you can have a higher level of confidence that the code being added to the system is of a reasonable quality. The last thing you can do, and probably one of the first things you should do, is you should actually talk to your developers. The people who are working on the source code all the time know where the pain points are. They know where the bodies are buried. They know what function they scroll past all the time that drives them a little bit crazy. They can tell you what to fix. They're actually going to know better than any of these other utilities, right? So ask them, what should we improve? If I plan a sprint 2 weeks from now, what should I include? How much time do you need to fix some problem? Ask them what their pain points are, what slows them down. They know what they are, and they can probably tell you, and it's probably been frustrating them, and they'll be able to tell you how to fix it. Okay, strategies for debt management. So we know we have problems, and we've hopefully figured out some utilities we can use to find the problems. How do we invest time into resolving them? How do we implement a plan to resolve those technical debt issues? The first question that people often ask is, we've got so much debt, should we just rebuild? Should we just start over from scratch? I would say probably not. Our code base is 200,000 lines. Rewriting that from scratch would be impossible. It'd be like starting WordPress over from scratch, right? Now, you might do some things better, you might do some things differently, but it's just such an enormous undertaking that it's just not reasonable. First off, there's no guarantee that you are going to be a better developer and do things better than you did the first time around, because why would you? You haven't fixed your old code. Why would you fix the new one? That's the first problem. The second problem is, do you even have enough time? Because you have to maintain the old system still, probably, right? You've got people relying on that. You have to fix bugs. You have to fix features. Management is asking you to do things. So you probably don't even have enough human resources or developers on your team to both maintain a system and try to build a new one. It's extremely hard. And the fact is that basically most rewrites from scratch pretty much fail before they ever get released. I don't have a statistic to prove that, but I have a lot of experience, and most rewrites just don't ever get off the ground. They never leave the development team. It's a good idea, we want to do it, it never gets out of the team. It just doesn't happen. So I recommend refactoring. Refactor things over time. So how do you do that? How do you refactor effectively? First off, start small. Do not try to fix all the warnings in one big commit and say all the problems are fixed, push, and then break the system. Right? That's not a reasonable way to do it. What I like to do is I like to create new versions of functions, and I call them like the blessed version. This is the holy ground. It shall not be touched. It should always be tested, and only really good code goes into this section. All the bad code's over here in this library, all the good code's over here, and anything that goes into the good section shall be perfect in terms of code quality. Once you have that new version of code, you simply swap them, right? It's really easy. Now, it's easy with low-risk code. The big problem is high-risk code. A lot of times, especially with legacy systems, you've got edge cases. The good thing about legacy systems is that a lot of the edge cases have already been addressed. This weird thing happens when Joanne down in the sales department clicks this button, and we wrote this stupid hack around to fix it, and we don't know why, but there's a fix. If you write a new system from scratch, first of all, you're going to miss that kind of stuff. And if you add new code into those particular things, or you're trying to rewrite it, you might miss it as well. So the best thing to do here is to write your new blessed version and then leave both versions running and actually call both of those versions when they're being utilized. So if you have some function that does something, returns something, leave the old version, implement the new one, and log the output of both of them to a log file. And just leave the old system running, leave the old function running, call the new function and just log the output, and then check it. Anytime the output doesn't match, figure out why. What happened? Why did this thing return differently, the new one return differently than the old one? Is there a bug in the old one? Is there a bug in the new one? Do we need a test? What can we do to fix this? Get them to be the same. Let it run over a couple of weeks if you have to. Once they're matching and you're happy with the fact that you've either fixed a bug or something like that, then you can go ahead and swap them out, and you have a pretty high level of confidence that you're not going to break it. All right? That's the best way to slowly move code from the old code to the new blessed code. If you decide to go down the path that I do not recommend in terms of rebuilding, there are a couple of things that you can do to make sure that you're successful. There's a strategy called the Strangler Application, literally like strangle. And what that means is that you basically build the new system on top of or around the old system. It's kind of like the approach of the new blessed version of code. But basically with a web application, what you can do is you can start routing requests based on Apache, take a request from the old version and pipe it into the new one. And so what you can do is you can rebuild a new feature in a new system or a new code base. And you don't have to tell the user that you're doing this, but when they click a button, it now no longer goes to the old system. It actually routes in the background and goes to the new system. They don't even know. You don't have problems that you would normally have where management is saying, when's the new system going to be ready? Whenever it's ready, whenever we have all the features re-implemented. We're not doing this on a particular timeline. We're not trying to release this by January 1. None of that. You're just rebuilding one feature at a time as you can and slowly redirecting the user from the old one to the new one, feature by feature by feature, till you have it all done. That's the best way that you can do this. And then once you've got all the features done, you just pull the old system down. It's a shim. You don't need it anymore. It goes away. The users never even have to know that you did it, right? Maybe they'll notice it's faster or works better and that kind of stuff, but you've basically replaced it without them ever having to mess with it. Last thing I want to mention is if you do refactor or you do rebuild, you're going to have to figure out how to increase your velocity. Right? We talked about velocity. How much work can you get done? If you're doing those two other things, like maintaining a new system and building an old one, or doing a lot of refactoring, you're going to slow down. And your development team is going to be asked, why are you guys going so slow? You need to produce the same amount of work that you used to be able to do when you weren't doing all those other tasks. So there's basically two ways that you can do this. The first thing you can do is you can pay off debt. Right? So we looked at the debt chart. We know that there's debt in the team. Well, what if we planned a whole sprint where we just tackled some big categories of technical debt and we paid it off and we rewrote some area of the system that was particularly painful? Well, now the team has a lot more resources because that debt is no longer in the chart, right? So the next sprint, they don't have to be slowed down or encumbered by that debt, so they can produce more features. That's one way to do it. The other way to do it is basically add team members. You just have to add resources. Those are basically the only two things you can do is basically make yourself more productive or add more people and increase productivity that way. That's it. That's all I got. Are there any questions? Yes?
I can get all this, right, so I can show my boss and stuff?
Yes. I haven't posted the slides, but I will make an effort to do that. And I know WordPress TV has intentions of posting it, right? Yeah. But yeah, if you want, I can definitely send you the slides directly, or I'll put them on my website or SlideShare or something like that. Cool. Anything else? Yes. Yeah, SonarQube. It's called SonarQube, QUBE. It is and actually I was just talking to somebody about this earlier. SonarQube is I believe it's Java-based. It's a Java application. It's a web application that you install, just like WordPress. You install it on a web server. And by default, it supports a number of languages like C, Java, JavaScript, PHP, that kind of stuff. It does not natively support Perl, which is really a pain for me. So I'm trying to figure out how to write a parser for Perl for that. But it's really, really good. I have been trying to get my team interested in using it. But basically, it's a dashboard that will index your code. So you look at it, and it looks like you're looking at GitHub, right? You can see the names of all your code files. If you click on them, the source is there. And it will index and tell you, this line has tabs and not spaces. This line needs more comments, because there's not enough comments in this code. And you can use tools like PHP Code Sniffer or PHP Unit Test, and it will take the results of those tools. So those tools output data files of all of your source code and the test results. And SonarQube will consume that data and give you an interface that you can click through, and it'll show you all the areas in your code. And it gives you health metrics. It'll tell you, well, this code is really messy or buggy. And what's really cool is you can look at a file and you can make some changes, commit, re-add the code, and re-index, and you'll see the metrics go up. And it's really cool because you're this file used to be an F and now it's an A. It's really cool. It's improving accessibility on your site or that kind of stuff. It just, as you fix problems and make errors go away, it looks really cool and you feel like you've been successful. SonarQube, really cool. Anything else? Cool. All right. Well, yeah, go ahead.
Usually the people making the decisions in the company is always money focused.
Sure.
I like how you got this financial vocabulary. Is there a formula or way that you can calculate to show someone that just goes by the numbers to show return on investment? Say, if we handle our technical debt, this is actually what it's going to look like with the company at the beginning of.
So in terms of their pocketbook, I don't know if I can, without understanding the business and all that kind of stuff, it's really hard to say. But I can tell you from a productivity standpoint, there's definitely a way to do that. So do you guys use something like Scrum? Okay. Do you use any? Okay. Yeah. Okay. Yeah, I get that. Yeah. The team needs to implement some sort of formal project management methodology where they can measure their performance. Because if you can't measure your performance, you can't explain to someone that you could be performing better, right? It's really hard to do that. So they need to adopt something. So Scrum is an option. There's tons of other things, but some official way of saying, in a normal week, we can execute on average 50 items in our team. And if we pay off technical debt, after we do that, the following week, we can execute 100 items. And that should be really, really plainly obvious to anyone who's in management to make a decision to say, all right, if you can do twice as much work, yes, I want to do that. Now, what's really potentially going to be a problem is if you find out that if you pay off that technical debt, you actually can't go any faster. Because that happens, right? So we have really big technical debt problems sometimes where this code is copy and pasted all throughout the system. It's been around for 10 years, and changing it would take 6 months. And living with it isn't really that bad. It's a little annoying, and maybe it costs us an hour or two, but is an hour or two twice a month worth 6 months of work to refactor that entire thing? The answer is no. So that's why like debt is complicated, right? You have to understand like the opportunity cost. You have to figure out, is this a decision that we should actually make? And that's why like measuring this kind of stuff is important before you say, well, I want to be able to work faster. You might find out that you aren't going to work that much faster. And this is, for me, has been challenging because I used to work on a team, or I used to work on a team of one, where it's just me, and I got to decide when I wanted to refactor things. This is taking me too long, I'm gonna rebuild it. I don't like the way this works anymore, I'm gonna change it. And then when you start working with a team, now like you don't get to like say whether or not the entire team participates in rewriting core architecture. Like it's just not feasible. So, kind of lost my train of thought, but basically, you have to know what it takes to do these things before you try to do them. You have to know, because the people do care. People want to make sure that you're providing enough value. And if you make a big change, maybe it actually isn't going to help anyone. Yeah. Anything else? Okay, cool. Vanity slide. There you go. Thanks, everyone.